Okay, so now that the AMCs are over, I thought it would be a good idea to just cover some of the problems. To everyone who took the AMCs, don't stress about it, you all did fine. I'll be doing problems 15 through 20 in this video. I probably won't do 20 through 25 because it would just make the video way too long. But if you have any specific problem requests, you can leave a comment. And yeah, I haven't seen any of these problems, the ones I'm doing in this video, except for 16, so hopefully I don't get stuck. Alright, so this is the 2022 AMC 10A problem 15. Quadrilateral ABCD with side lengths AB equals 7, BC equals 24, CD equals 20, and DA equals 15 is inscribed in a circle. The area interior to the circle but exterior to the quadrilateral can be written in the form a pi minus b over c, where a, b, and c are positive integers such that a and c have no common prime factor. What is a plus b plus c? Okay, so first let's just draw the diagram. We have a circle, and let's say we have a, b, c, d. So a, b, c, d, 7, 24, 20, 15. And we want to find the area, okay, of this region. So interior to the circle, exterior to the quadrilateral. And I guess the way we can do that is by finding the area of the circle and subtracting the area of the quadrilateral. Okay, so one thing we can do is probably, since the quadrilateral is cyclic, we know that the opposite angles sum up to 180. So let's say this is theta, this is 180 minus theta. We can use law of cosines to get an equation for length AC, and then probably we can solve for AC from there. So let's just do this part here. 49, we'll say this is x, AC is x. 49, which is 7 squared plus 24 squared, is 576, minus 2 times 7 times 24 cos theta equals x squared. And we can do the same thing for the other side. So 15 squared is 225 plus 400 minus 2 times 15 times 20 cos 180 minus theta. This is equal to negative cos theta, so we just make this a plus and then cos theta here equals x squared. And I guess now we just have to do the arithmetic. So this will be 625 plus 3600 cos theta. I believe that's right. Yeah. 625 plus 600 cos theta equals x squared. And in this first equation, we have 576 plus 49 is 625. And we have 14 times 24 is 336. That equals x squared. Okay, so we have these two equations here, which is basically just a system of two equations with two variables. We can set them equal. So 625 minus 336 cos theta equals 625 plus 600 cos theta. So these cancel out. And we get 936 cos theta equals 0. Okay, so the only way this is possible is if cos theta is 0, which means theta is 90. Oh. Okay, so then these are just right angles. I guess we could have just seen that because if this is 25, this would be 7, 24, 25, which is a Pythagorean triplet, and so is 15, 20, 25, that's 3, 4, 5. So now, then that just makes things a lot easier. Okay, so if these are both 90, then this means that AC is the diameter of the circle. So this would be 25. So the radius is 25 over 2, and pi r squared is equal to 625 over 4 pi. This is the area of the circle, so we just have to subtract the area of the quadrilateral, which is going to be, well, we have two right triangles, ABC and ADC. This is going to be 7 times 12 equals 84. This will be 15 times 10 is 150. So these are the two, this is the area of the quadrilateral. So 625 over 4 pi minus 150 plus 25 is 175, so like that. And we want to get it in this form of a pi minus b over c. So I guess we can just multiply 175 by 4. 20, 28, 30. Okay, 700. Okay, so we have 625 pi minus 700 over 4. And this is going to add up to 1325 plus 4, 1329. Okay, and that's not one of the answer choices, so let's see what I did wrong. Wait, so 7 times 12 is 84. Oh. Wait, okay. This is not, that's my bad. Okay, I confused myself because I circled 25 there, but the area was actually 84. Okay, so it would be actually 234, not 175. And then we just do the same thing. 234 times 4 is, okay, 936, 625 plus 936 plus 4, 625 plus 940. And this is, yeah, D1565. And yeah. Okay, on to the next one. This is going to be number 16 on the AMC 10A. The roots of the polynomial 10x cubed minus 39x squared plus 29x minus 6 are the height, length, and width of a rectangular box. A new rectangular box is formed by lengthening each edge of the original box by 2 units. What is the volume of the new box? Okay, so let's just simplify the problem. So we have the polynomial 10x cubed minus 39x squared plus 29x minus 6. And we're given that the roots are the height, length, and width of a rectangular box. So let's just say the roots are R1, R2, and R3. What the problem is asking us to find is going to be R1 plus 2, R2 plus 2, times R3 plus 2. Because that's the volume of a rectangular box, it's just the product of each of its dimensions. Okay, then we can just expand this. So this would be, well, let's just expand the first pair of parentheses, R1, R2 plus 2R1 plus 2R2 plus 4 times R3 plus 2. And then finally we have R1, R2, R3 plus 2R1, R2. Oh, I just broke the lead. Okay. And then we have plus 2R1, R3. Plus 4R1 plus 2R2, R3 plus 4R2, and finally plus 4R3 plus 8. Okay. Now we can just use Vietta's formula to just evaluate this entire equation. So from Vietta's formula, we know that R1, R2, R3 is going to be 6 divided by 10. So we can write that as just 3/5. And then now notice that we have the pairwise sum times 2. The sum of the pairwise products times 2, sorry. That's going to be 29 over 10 times 2, just 29 over 5. So I'll just cross these out. Plus 4 times the sum of the roots, which is going to be 39 over 10. So that would be 78 over 5. And finally, plus 8. So this would be 107, 110 over 5, which is 22, and plus 8 is 30. And I forgot to write the answer choices, but I think that is answer choice D, yeah. Okay, and on to the next one. This is the 2022 AMC 10A number 17. How many 3-digit positive integers ABC are there whose non-zero digits A, B, and C satisfy 0.ABC repeating equals 1/3 times 0.A repeating plus 0.B repeating plus 0.C repeating, and this bar indicates repetition. Okay, so we can just convert this into a number 3 problem. So instead of writing this as ABC repeating, we can write this as 100A plus 10B plus C over 999. If you didn't know, if you have a decimal, if you have a repeating decimal like this, the repeating part is just going to be this entire thing divided by the same number of 9s underneath. So since there's 3 digits here, we divide it by 99. And then on the other side, we have 1 digit here, so this is A over 9. And this is B over 9 and C over 9. Okay, so this is equal to 1/3 times A over 9 plus B over 9 plus C over 9, which is A plus B plus C over 9. So this is A plus B plus C over 27. And then, I'll just write this again, I guess. We can multiply both sides by 999 to get rid of the fractions. So we get 100A plus 10B plus C equals 999 divided by 27 is 37. Because it's 111 divided by 3, so it's 37. Okay, so we have 37A plus 37B plus 37C. And just cancel all the terms out, so 63A equals 27B plus 36C. Divide by 9, 7A equals 3B plus 4C. Okay. And now we just have to figure out the number of solutions to this equation such that A, B, and C are non-zero digits. So they're everything from 1 through 9. So our solutions are going to be, if A equals 1, B and C are going to be 1 as well. Okay, so our solutions always look like A equals B equals C. So we'll have A equals 2, B equals 2, C equals 2. And so on. So A equals 9, B equals 9, C equals 9. But I think we'll also have some extra solutions, so I'm actually just going to write them all out instead of doing this. Actually, yeah, I'll just write it down here. So, sorry. Yeah, I think it might have been better if I actually read the solution beforehand, but it's fine. A equals 4, B equals 4, C equals 4, equals 5, equals 6, 8, equals 9. I'm just writing them all out so it's easier to work. Okay, so these are going to be our solutions. But note that in this original equation, if we decrease b by 4 and then increase c by 3, well, if we decrease b by 4, we get minus 12. If we increase c by 3, we get plus 12. And that cancels out, and that gives us another solution. And similarly, we can do minus 8 from b, which is minus 24, and then plus 6 to c, which is plus 24, and that cancels out. But I don't think that's probably not going to be a case we have to consider. So let's just look at our cases here and see if we have any other solutions. So here, well, we can't decrease b or c by anything because then it's not going to be a positive digit, so it's not going to work. So this is just one way. Similarly, this will be one way. This one, well, we can have b equals 0, c equals 7, but a, b, and c are non-zero, so that doesn't work. That's going to be one way. I think this one will actually have two solutions. We can have b equals 8 and c equals wait, actually, sorry, okay. A equals 4, b equals 4, c equals 4. We can add 8 to b and minus 3 from c. Subtract 3 from c. So we have c equals 1, b equals 8, and that gives us two solutions for this case. We can do the same thing here. We could have c equals 8, b equals 1. We can also have b equals 9, c equals 2. So this goes just 3 ways. And then let's consider the next ones. Here we can add 4, and then, okay, so this would, actually no, we can't. Because if we add 4 to b, 1b equals 6, you get b equals 10, that's, but they're all digits, so we can't have any of them being greater than or equal to 10. Let's see. Oh, we actually still could do b equals 9 and c equals 2. Subtract, sorry. This would be, no, okay, yeah. So we could have c equals 9, b equals 2, sorry, yeah. Because we're adding 3 to c, and then we subtract 4 from b, and then it cancels out. We have the plus 12 minus 12 again. And then I think after that, we're not going to have any other cases, because we can't add 3 to c or add 4 to b, because then they're both going to be greater than 10, or one of them is going to be greater than 10. So these are our only solutions. So we're just going to have 9 plus an extra 1 here, and then plus an extra 2 there, and plus another 1 here. That's going to be 13, and that should be equal to D. So just to summarize, what we did was we wrote down all the solutions and then shifted B and C to figure out the other solutions.